Well, yeah, it's trying to open up the Smart Notebook. Sorry. I need to learn to have this thing started up when I come to class. I had it on sleep mode yesterday. Something put it, like, killed the battery on it. Here it comes. Band people, I'm sorry that you got this day for your competition. It's a competition, right?
Yeah.
Kind of. It's like a friendly.
Yes.
Well, we're gonna smoke them either way. So
Yeah. Just
How many schools are going to be
It's
here?
it's more like a festival.
Yeah, it's
Not like
just
a competition.
But you get ratings, don't you?
Yeah.
You do.
other people get the vision on
Why is it taking so long?
Come on, Nathan.
What's this got to do with Nathan?
Nathan wants to destroy all windows.
Oh.
Be a lot of money.
Come on. Well, we don't have all day. The questions. What, okay, there it is.
Nice.
See, I heard me threaten it.
I think you opened it up twice.
Oh, yeah.
Oh, never.
Just had that introduction thing. Shoot, I didn't have that program, the file open on this computer. Yeah. Shouldn't take any time at all.
Yeah.
Didn't every teacher do that?
No, only the teachers that got these boards, and so I'm only in here 1 hour in the day, and so I didn't get the Mac.
Max fast.
I mean,
There are teachers complaining though about the Macs and how they sometimes have to. It restarts on its own or it crashes. There's some frustration with these new ones. Okay. Where's my? Oh my gosh. Okay.
Your life is so difficult. Just say
I know.
about it.
Did you mean to do that?
No, but I fixed it.
Okay, J Deep, sorry about this. All right, well, I'm a mess right now. I don't have my file. I don't know if I have to restart. Nope, that's not me. It should say there's a J Moore. I don't remember what drive, the iDrive maybe, and it's not showing up.
where's your guy?
Oh man. Okay, my friends. Well, I guess I restart. So you're just gonna have to take my word for it. What I tell you up here. The problem said that we had. Okay, let's see if I can remember
You
it.
should probably tilt the iPad
So
back
that
to
you can see the board.
I got it. Oh yeah.
Maybe I'll go old school.
My place is shocking.
Might as well.
Okay.
Oh, okay.
I'll just do that. JD, can you see me? Yes? Okay.
Yep.
So let's see. The problem said that we had, I believe, 100 milliliters of 0.4 molarity. That must be what it was. And so from that we came up with, there are 0.04 moles of that compound. You with me on that? 0.1, we need to move the decimal over 3 places. 0.1 liters times 0.4 molarity gives us 0.04 moles. Yeah, so these two were what I used to determine that. There's 2 coppers in every one of these. So when this dissolves, as you know, the coppers break apart from the sulfate because it's a soluble compound. And because there's 2 coppers in each one, if there's 0.04 moles of this compound, there's 0.08 moles of copper. How many moles of sulfate would there be? 0.04, right, because there's 1 sulfate in every compound, but there's 2 coppers. So that doubles the concentration of copper ion. That's where I get that. Any other questions about this problem? Yes.
Where'd you get the 0.2 liters?
Oh, because there was 100 milliliters of the copper solution combined with 100 milliliters of the phosphate solution. So when we combine the solutions, you have to, when you find a final concentration, it's got to be divided by the total volume after you combine it. Please wait. Okay. Now, I just did this lesson last hour. What was my next example? I'll see if I can just do this from memory. That was going to be the last precipitation. I was going to go on then to acids and bases. Okay. Yeah. Yeah, I do remember right now what I'm. Yeah, I guess if you printed them out, I might ask to borrow that. Who was it that said that, Sophia? Thank you. I'll come grab them in a moment. Oh, you don't have them?
Got it.
Oh. Did you print them out?
No,
Okay. Anyway, what I was getting at next was there are a couple of definitions of what acids and bases are. Acids and bases have been used for a long time in chemistry. Hundreds of years ago, people, even before they were scientists, knew that there were some compounds that would dissolve metals. Those are pretty special kinds of compounds that will dissolve metals. Even like gold, you can dissolve gold if you have the right combination of things. The definition of acids and bases have kind of evolved through the years. The first definition was proposed by Arrhenius. I can't remember how to spell his name.
I think there's an H.
Yes, I don't know where the H goes though. So yeah, Svante Arrhenius was his name. Yeah, that's fine. Thanks. Oh, it'll have the right spelling on that too. Thanks.
Can I use my phone to look at the notes?
Yeah, it's fine. You don't have to ask me if you can use your phone. That's no problem. Yeah, you're real funny, Emily. They're out of order. Oh, no, they're not. Just the top page. Yeah. Did I mention that I'm a mess? Oh, we could. Yeah. You guys, you're so sharp.
Draw it right there.
Oh, and now I have my drive back, too. So after all that trouble, but while that gets going, that is a great idea. I'll just put that on here. So Arrhenius' definition, and by the way, it was spelled right. Oh, nice. Yeah, that could be read. If we turn this back to the smart board. Thanks. So Arrhenius described acids as any compound that would release hydrogen ions into water. That generally is, no matter what definition we use, that's what everybody says an acid is. Acids produce hydrogen ions. The big difference is the base, the definition of base. Arrhenius was the first person to propose a definition of what acids and bases were. And at that time, things were much simpler. So he suggested that bases are any compound that would release hydroxides. Sodium hydroxide, lithium hydroxide, potassium hydroxide. Any metal hydroxide compound you put into water, those ions break apart from each other. You get hydroxide. We later learned, we being the world of science, this is way before I was around, but it was later discovered that there are some compounds that don't have hydroxides in them, yet when you put them into water, there are hydroxides that show up. That was discovered by Bronsted and Lowry, two guys who were working together. And this, I believe, is the late 1800s now. Svante Arrhenius was the mid to late 1800s. We will study acids and bases in a chapter by itself. That's chapter 14 in the book. That's right after the holidays. We'll get into chapter 14. But for right now, for this entire chapter, we're just going to go with a very simple Arrhenius definition of what acids and bases are. And that is going to keep things simple for us. Because an acid is something that produces hydrogen in water, and a base is something that produces hydroxide in water, a neutralization reaction is one in which the acid and the base are undergoing a double replacement. The hydrogen leaves the acid, the hydroxide leaves the base, and they're going to go together and make water. The counter ion meaning whatever the negative ion with the hydrogen was, and whatever the positive ion with the base was, they'll join together and they'll make this other product. In general, we call that a salt. A salt, if we're not in chemistry class, when I say salt, you think, oh, French fries, right? But in chemistry, salt means any ionic compound. So that's what we'll have, is we'll have a negative ion from the acid, a positive ion from the base, they'll join together, and that's the other product of a neutralization. Now, neutralizations are actually simpler than precipitation problems are, because in a neutralization reaction, the acid and the base both have to run out at the same time. For there to be a true neutralization, you need to end up with a neutral solution at the end. That means you can't have an excess of either one of these. So that's what makes neutralization reactions a little simpler. Really, they are. They're not bad.
So there's no limiting reagent
Right.
for a neutralization one?
That's right.
But there will be a limiting reagent for like a precipitation?
There usually will be. There doesn't have to be for precipitation. They both might run out at the same time. But they will run out at the same time for neutralization. When you did titrations, you remember doing titrations, you were using phenolphthalein as an indicator. You remember what color phenolphthalein turned?
Pink.
It goes like a pink color. Yeah. When phenolphthalein is an acid, it stays clear. When it's in a base, it turns pink. So you normally will titrate, putting the acid into the flask first. The base will be in the burette. Add some phenolphthalein and swirl it. Nothing happens because phenolphthalein and acid is clear. Then you start adding the base to it. And over time, as you add base, you start to see flashes of pink. You swirl it, pink goes away because it's still an acidic solution. When do you know to stop adding the base?
When it's slightly.
When it makes a very slight pink color. The lighter the pink, the better. Because if it goes a real pink color, and you say, okay, well, there I am. No, you didn't quite hit it. You have gone past the endpoint, and now you actually have an excess of base in there if it's a real bright pink. But if it's a very faint pink color, you've just barely added enough base, and it's close enough to just say that it's... What we want in a titration is we want in one drop for the solution to go from clear to pink. In one drop. So you need to be so close to the equivalence point. And that's what we're trying to get to in a neutralization. And this is specific just to neutralization. We call it the equivalence point. It is the point at which the number of moles of acid equals the number of moles of base, and there is none that runs out first. They both run out at the same time. Yep. And the only way we'll know that with phenolphthalein is if it goes a very slight pink. Because if it stays clear and it's right at the end point, you don't really know. Okay. So anyway, that's what we'll be doing. I'll talk more about the lab if I ever get there this hour. I wanted to show you a couple of problems that involve... I know it'll take some time to start this program, so I'm going to see if I can bring it up and then show you the question. Okay. Now the next slide would have, and I would not have left it on this thing, the strong acids and the strong bases. I'm not leaving this up here. I do like that picture, though. I'd like to show you the picture. It is loading the document. Oh, good, it's going to come up. Take a look at, I know it's not up here yet.